everybody. For this unit, I wanted to go over something that I noticed when I was grading your tests, and that is I'm not sure if you know how to use these tools because only a few of you use them. Okay, specifically this button here, and then also this button here. Okay, and so when you click this button, what it'll do is allow you to fill in this box with whatever you want the exponent to be. If you want it to be x to the negative second power, you can enter that in there, and I'll show you that in a sec. This other button here is for making a fraction. And if you want, you can make a fraction with x to the negative second power in it, okay? You can make the denominator x to the fifth power, whatever you want, okay? So let's take a look at what that looks like. It's on page 4 here, some practice problems, okay? And I'm gonna do these second two, no, I'll do all of them. So this first one, the best estimate, what they want you to do here is round to the biggest possible value, okay? This is just really kind of spitballing it, as they might say, but just a really, it's about this much, okay? So the best estimate for 18,423,850, we're gonna say, that's about 20 million, okay? I rounded up to the highest place value, and I said this is 20 million. All right, in this one, we're gonna rewrite this with an integer power of 10, okay? And in this problem, that means how many times would you have to move the decimal until there's only one number in front of it? Okay, the 1. And so I would have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Okay, so this is 10 to the 10th power. All right, so I'm going to type 10. I'm going to hit that X to the little box button, and then the power here is going to be 10. So you can see it typed it with the exponent. Let's do this one. Okay, this time I have to move the decimal to the right. I'm actually making the number bigger here. This is a little small number. So I'm going to move it 1, 2, 3, 4, 5, 6 to the right. That means it's 10 to the negative 6th power. Okay. Oops, I don't need that just yet. Uh-oh, uh-oh, uh-oh. Okay, whew, back arrow. Okay, 10. Then I hit the X to the little box. See how it moved the cursor up? And now I can type negative 6. Okay. I'll check my answer. All right, got him right. Okay, that's that. Let's look at a couple other things in the lesson. The first thing that I wanted to look at here was vocabulary, because I didn't know if you knew this word here. I just wanted to point it out. Okay, look at these two here, large quantity and small quantity. Large quantity, a measurement that is huge in size or magnitude. Okay, I just wanted to be the one to tell you magnitude has nothing to do with magnets. Okay, this is not about magnets. This is about, hey, it's big, or hey, it's small. It's about size. Okay, so here they say size or magnitude, meaning size equals magnitude. These are the same thing. Okay, they're synonyms. The magnitude means big or small. Okay, so here you see it again in small quantity. A measurement that is minute. Minute means small, guys. In size or magnitude. Okay, that's all they're talking about there. I just wanted to talk to you about it because I thought it was kind of hard to understand. A little bit tricky there. All right, let's go to some problems. Let's do this one. I'm going to zoom out a little bit so that we can also see this chart of the negative powers of 10. We're going to use that. Okay, so if I look here, it says 1 kilometer is equal to 0.6214 of a mile. Express this quantity in the form of a single digit times an integer power of 10. So I'm going to have a 1-digit number, 1 digit only, times 10 to some power. Okay, and to get that, I'm going to have to move the decimal. Okay, so if I move it one place like this, okay, I get 6.214, okay, and I basically, because this number, see how this number was in the 10th place? I'm going to give it the exponent of -1. Okay, and then I'm not allowed to write this stuff. I'm only allowed to write 1 digit. So are we closer to 6 or are we closer to 7? I'd say we're closer to 6. Okay, and that's that. I'm going to stop here because my family got home, and I'll do a second video to continue. Thanks, guys. Okay, actually, I'm just going to keep going. I figured out how to pause it. So let's do the next one here. And if you look at question 2, it says company X reported a total gross sale of 4 times 10 to the 8th power in dollars for 1 year in 2019. In the same year, company Y reported a total gross income from sales of 7 times 10 to the 9th in dollars. Using what you know about scientific notation, make an inference to determine whether company X or company Y had the larger gross income of sales. Then solve to determine how many times larger. Okay, so, and I've got the answer showing here because I didn't want to mess this one up. Okay, so company X is 4 times 10 to the 8th power. Okay, and then company Y is 7 times 10 to the 9th power. Okay, so if I were guessing here, this is what I would do. I would say, well, I know 4 times 2 is 8, right? So this is about 8 times more. And then I know to go from 10 to the 8th power to 10 to the 9th power, that's about, oh gosh, I put the wrong number here. It's about 2 times bigger, sorry. And then 10 to the 8th times 10 to the 9th is 10 times bigger. Okay, so my guess is it's about 20 times greater. Okay, and you can see I'm right. It's 17.5 times greater. And then let me just write it. This is company X, and this is company Y. Okay, so I'm guessing here just by using what I know about numbers to say that company Y has the greater profit, and it's about 20 times larger. Okay, so how do we do the actual work here? Well, let me show you that. Let me erase a little bit of my guess here. Okay. If I want to know how many times greater, so basically company X times what would equal company Y. What I really want to do here is divide. Okay, it's the same thing you would do if you had like an equation like 3x is equal to 72. You would divide by 3 on both sides to figure it out. Okay, and you do 72 divided by 3. So that's what I'm going to do here. I'm going to take 7 times 10 to the 9th, and I'm going to divide by 4 times 10 to the 8th. Okay, And then what I'm going to do here, I'm not going to rewrite those with all the zeros. Yuck. I'm going to use my quotient rule. Okay, I'm going to say this is 7/4 times 10 to the power of 9 minus 1, right? Let me move myself over here. Okay, and then what's 7 divided by 4? I don't know. Let me just calculate that up. 7 divided by 4 is 1.75. Okay, so 7/4 is 1.75. And then 10 to the power of 9 minus 1 would be 10 to the first power. Okay? And I mean, guess what? Look at the answer here. So if you have 1.75 times 10 to the first power, that's just 1.75 times 10. Okay? The 10 to the first power is just going to move the decimal one place to the right. Okay? This is what it means to be times 10 to the first power. So look how little work that really was when I used my powers of exponents. Okay? I split up the fraction. That was the key to doing this part here. I split it up into just the number divided by the number, and then for the powers of 10 here, I used the quotient rule. Okay, and then after I had my scientific notation, I said, hey, this is just times 10, right? 10 to the first power is times 10. And I know I can multiply by 10 just by moving the decimal one place to the right. Okay, so either way you get 17.5 as your answer there. Let's look at another one. I'm focusing on the word problems here because I know those are hard for people. This is one of the practice questions, and it says 1 week before an examination day, a librarian monitored the number of students who visited the library. Then they compared it with the number of visits made in an average week. Approximately 2 times 10 to the third visits were reflected in their logbook during this 1 week period, while only 5 times 10 to the second power were reflected on an average week. How many times higher is the number of library visits before examination day compared to the library visits in the average week? Okay, so we have 2 times 10 to the third, okay, and that is library. Is this the exam week or the? Okay, so this must be the exam week. Exam means test. Okay, so there was a big test. And then the regular week was 5 times 10 to the second power. Okay. So how many times greater was this? Okay. So one thing you could do, I mean, these numbers are so familiar. I might know that this is 2,000 because 10 to the third power is a 1 with 3 zeros. That's 1,000 times 2. And then this one here would be 500. Okay. And then maybe I just add some symbols here to make this an equation. 2,000 equals what times 500? Okay, so I can divide by 500 on both sides of the equal sign. We're gonna need our equations this year for sure. This is a nice little one-step equation. Okay, and guess what? When you divide these zeros are going to cancel out. Check this out. Okay, oops, not that one. Ugh. Okay, there and there. Those zeros will cancel out, and this will just be 4. 4 times as many. All right. You can divide this in a calculator. You can rock some long division and make sure I'm correct here. But in this big problem, I'm just getting 4 here. Okay. That's all I've got. Do you want to see it the other way? So if we had 2 times 10 to the third power, and I divide it by 5 times 10 to the second power, I can split it up 2/5 times, use the quotient rule, 10 to the 3 minus 2. Okay, 2/5, that's the same as 4/10, 4 out of 10, right? So that's just 0.4. You could do that in the calculator if you didn't remember 2/5. 3 minus 2 is 1. Okay, and so here I have 0.4 times 10. 10 to the first power is 10. And to do that, all I have to do is move the decimal 1 place to the right to multiply by 10. Okay, same answer, 2 ways. All right, guys, have fun. I love this stuff. I hope you like it too. Thanks for watching.